The topic for this video is the wonderful electron. The essential questions are: what is the Aufbau principle, what is Hund's rule, and how do you use these to write electron configurations? Okay, so just a quick review of quantum theory. We're going to use an analogy of an apartment building. An atom is like the apartment building. Okay, the nucleus, which is inside the atom, is just like the ground floor. The energy levels are like the floors above. Okay, so moving away from the nucleus, just like the floors above move away from the ground floor. The sublevels are like the apartments. So the sublevels are inside the energy levels, just like the apartments are on the floors. The orbitals are like the rooms. So again, orbitals are inside sublevels. And the electrons are like the people. So the people live in the rooms, the electrons live in the orbitals. So we have different types of orbitals. The first one is S. S you can think of as spherical, and it's a one-room apartment. So it has one possible shape. The P orbitals have the shape of a dumbbell, and they can be in three different directions. The X on the X-axis, on the Y-axis, and the Z-axis gives us a three-dimensional shape. So we have three different rooms, three different possibilities. On the D orbitals, there are 5 different possibilities, so that's like a 5-room apartment. And on the F, that is like a 7-room apartment. So you can see a pattern here. As you go, they are going in odd numbers: a 1-room, 3-room, 5-room, and 7-room. And on the F orbitals, you don't have to really worry. They're pretty complex shapes. Just know that's number 7. Same is true with the 5, but you should be able to understand the 1 and the 3 and the different dimensions that they're in. Okay, so if we take a principal quantum number, which is n, let's say we have 1. That means we have 1 energy level because those are going to be the same. It also means there's 1 sublevel. And so that type of sublevel is a 1s. It has to go with the simplest form. Okay, so there will be 1 orbital and 2 electrons. And on this, I know you don't know what all of these things mean. Just look for patterns here. Okay, so the principal quantum number of 2 has 2 energy levels and 2 sublevels. So it's going to have a 2s and a 2p sublevel. So now if you remember, there was 1 room in the s, but there were 3 room in the p orbitals. So that makes a total of 1 and 3, gives us 4. So the max number of electrons, we can have 2 in each orbital, so 4 times 2 is 8. On the next one, we have 3 as our principal quantum number. So we have 3 energy levels and 3 sublevels. So now we're going to go one step further: 3s, 3p, and 3d. Okay, so we had 1 orientation in the s, 3 in the p, so that makes 4. And then we have 5 in the d, so that makes 4 and 5 make 9. The maximum number of electrons is the number of orbitals times 2, so that would be 18. Finally, if we have a principal quantum number of 4, we have an energy level of 4 sublevels. We go all the way to the F, so 4s, 4p, 4d, 4f, and then the number of orbitals is 16, because we have 1 in the s, 3 in the p, so that makes 4, 5 in the d, so that makes 9, and 7 in the f. 9 and 7 makes 16. That gives us our max number of electrons of 32. So to find the number of orbitals, you just have to take that principal quantum number and square it, and then multiply that number of 2 to find the number of electrons that can fit there. Again, this unit is a lot about patterns, so that's what you need to be finding. The electron configuration is kind of like the address of the electron. Just like I could most likely expect to find you at your address, even though you may be out running an errand at school, someplace else, that's the place I'm most likely to find you. The same is true with an electron. For neon, the electron configuration is 1s2, 2s2, 2p6. That first number is the energy level. The combination of the energy level and the letter, that's the sublevel. So like 2p is a sublevel, 2s is a sublevel. And then what looks like the exponent is the number of electrons that can fit there, or actually that are there. So the rules for writing electron configurations. We have to follow the Aufbau principle, which says the electrons enter the orbitals of lowest energy first. They're going to go in the 1s orbital before they go in the 5s orbital because that's a 5th energy level. We also have to follow the Pauli exclusion principle, which says that only 2 electrons can occupy an orbital. Okay, we said 2 electrons to a room. And they have to have opposite spins. And we note that when we do orbital diagrams by putting an up arrow and a down arrow into the box. And the box represents an orbital. And each arrow is an electron. The Hund's rule is when electrons are assigned to equal orbitals, 1 electron goes in each orbital before being paired. So if we have a p orbital, remember there were 3 rooms there, so we draw 3 different boxes. And since they're all on the same energy level, they would like to spread out. If there's only 3 of them, they're each going to have their own room. Just like you wouldn't want to share a room if you had enough rooms in your house for everybody to have their own. So if they have 3 rooms, they're not going to double up first if there's only 3 of them. Okay, so this is what's called the Aufbau diagram, and it basically shows you the pattern in which you're supposed to fill the orbitals. This represents an energy level. Those are the sublevels, like the 5D, 5F, 4S. Those are sublevels. And the little exponent is the maximum number of electrons that you can put into that spot before you have to overflow to the next area. So some sample electron configurations. Hydrogen is number 1 on the periodic table, so it has 1 electron. So it's going to go in the 1s, and it will only have 1 electron in there, so it's 1s1. If I want to draw the orbital diagram, I would draw 1 box with 1 arrow in it because I have 1 electron. Helium is number 2 on the periodic table, so it has 2 electrons, so that's a 1s2. If I wanted to draw my orbital diagram, I would draw 1 box with 2 electrons in there. Lithium is number 3. Okay, so now we have gotten to the end of the 1s orbital, and so now it's going to overflow into the 2s orbital. So you notice the exponents have to add up to the total number of electrons. 1s2, 2s1. My exponents are 2 and 1, so that's my 3 electrons. And if I draw my boxes, I have to put my electrons in my 1s box first, and then in my 2s box. Okay, now let's do one that's a little bit longer. The nitrogen has 7 electrons, so it's going to go 1s2, and then we still have 5 electrons left, so it's going to overflow. So it goes into 2s2. Now we still have 3 electrons left, so it's going to overflow. So I have 2p3. Remember, those p orbitals can fit 6 electrons in there before they overflow. So if I want to draw my orbital diagram, I have my 1s box, my 2s box is full, and remember Hund's rule, I only have 3 electrons in this last section, so it's going to be my 2p orbital, and I'm going to spread them out 1 in each orbital. Okay, with iron, I already have part of it drawn here. I have 26 electrons, so I have 1s2, 2s2, 2p6. That's my first 10 electrons right there. Then I'm going to overflow into my 3s2, 3p6. Then it goes to 4s2, 3d6. Okay, and now I'm at 26 electrons. So I'm going to have to finish my orbital drawing here. I've done the first ones for you. We have 4s2, and my 3D box has 5 boxes to it. So my 4s is full. And remember, they want to spread out. So I have my 3d5, and then one of them has to double up because I have 6 electrons in there.